Hello everyone, my name is Jonathan and I'm going to be explaining my thought processes and code behind this genetic algorithm project. Now this project was made basically for like a transport company like I guess Up or FedEx or any of those places. We basically take in a bunch of packages or parcels and you can only load so many of them onto a truck. And so you want to have the most valuable piece of cargo that you can possible, and as such it has a maximum threshold of weight and then a threshold of value as well. It can't go over the weight, it needs to go over the value. However, the items inside need to be of a certain value. And so the way I did this algorithm was pretty clever, but we're going to get to that in a bit. Timestamps should be added to the video below, so if you want to skip ahead to any particular piece of the code that you want me to explain, you can do that. Right then, so let's just begin. So this is just the main section of code here, the main thing. This is just for inputting the file naming and everything like that, reading from the file to get the information on everything here. Anything that you see that's commented out is probably either debugging or is not necessary code that I can then remove, something I was experimenting with. Right, so then you get to the point where it actually runs the algorithm, and it runs the exact same way as a regular genetic algorithm does. It creates a population. It sorts that population out into the best and worst, and it culls the worst part of the population, and then it breeds and mutates that population to become a new population, and so on and so forth. And it does this just the same as any other genetic algorithm would. It's got a counter to count through and to test against the termination counter, because you don't want an algorithm going on for too long. So if it can't find a solution within a certain number of within the termination count, it will terminate itself. Or if you're looking for an option that I put in was find the best possible solution, which means that it will continue running the algorithm to find the best possible solution. Otherwise, it'll just, once it meets the threshold, it will stop the program then. Well, I shouldn't say the best possible solution, the best probable solution, because there's always a 0.01% chance that there was a better option out there. But that's just math and computer science in general. Right, so that's a boring piece of code out the way. Now to get to the beating heart of the operation here. The actual cargo class itself, which has all the genetic algorithms into it. So it gets a parcel class is basically just sets the name, the weight, and the value of the parcels, and then turns that into a list of parcels over here. So it creates a population here using population numbers and everything like that. This population number is very specific. I didn't come up with it. I googled what will be the mathematically best population number for like varying sizes of code, because you don't get the same number of parcels every single time. We were set a limit of 40 parcels. I believe was the maximum number of parcels that we're going to be given. So you're going to be seeing a lot of my code is based around that number of, we're going to have a maximum number of 40 parcels. But this program is also made to scale. It's meant to scale well. So you could put in, I could modify some code and then you could put in 1 million parcels if you really wanted to, and it should still run pretty well. Right. So moving on from there, it then sorts the population. This is a basic bubble sorting algorithm, a very basic algorithm. I know I could have done a merge sort here, or a better form of sorting thing to sort the population out. Why did I choose bubble sort? It's simple, because we've got a low population. So the runtime would be bad for bigger populations, but since we've got such a low population, it doesn't really matter, and a bubble sort is simple and easy to do. So that's why I used it. If we had a bigger population sample, I would use a merge sort. Or I would use a tournament method for sorting the population out. Tournament method is basically when you take two members of the population and then you decide which one's best, more fit, and then you cull the other one, which is absolutely brilliant runtime of returning on big O, because it's big O of n, whereas this one here I believe is big O of n factorial, which is a lot worse, but it gets the job done. If I have some time, because I'm working on some other projects at the moment, I will code in the tournament method as well. Get fitness function. Fitness is very simple, obviously. You want the best. You want the best value. You want from the thing, and that's the value is the fitness basically. And if it goes over a certain weight, then the fitness drops to 0 because you can't have it going over certain weights, and so that's the criteria for that. Get cargo weight, prune population, all that standard stuff. Breed population is just a simple. It's a very simple breeding method. It's basically just splices two random members of the population together. There's nothing fancy going on there. It doesn't choose random indexes or anything like that to swap. It's just a very simple one there. I didn't think it had to be too complicated. But this, and the children as well, creating children is basically just splicing the two together and then mutating them. But the mutation method is where the real, the cleverness comes into my, I believe is the real clever part of this whole algorithm that I made here. Well, this whole program that I made. So, the mutate method, usually we were told, when I was in university, that genetic algorithms usually mutate randomly. Now, it is still important that it is random, the mutations. But what I've done here in the code is I've actually made it so that it mutates with purpose. It's almost like selective mutation to some degree. Everything will still be random, but it won't have an equal chance of everything happening. So, for instance, if the particular genetic sequence is found to have an item is found to be overweight, it is going to remove an item from the list that is of a lower value, more likely to remove an item of a lower value from the list. So it's more likely to change a 1 to 0. And then the likelihood of whichever one being chosen to move to a 0 depends on the value of the item. The higher the value the item is, the less likely it is to be chosen. The lower value it is, the more likely it is to be chosen. And the opposite is true. If the items are not quite of the right weight capacity, it will add an item. It will take a 0 and turn it into a 1. And the likelihood of this being changed is higher for higher value items. Again, still completely random. Well, not completely random. It still would be random. There's a chance that the worst value item would be chosen, which is very, very important, because otherwise you're going to be stuck on it would be possible, at least, to be stuck on an infinite loop. That randomness is still very, very important with the algorithm. But this here makes it incredibly efficient, this particular algorithm, because every single iteration is almost guaranteed to be better than the last. You're not going to get some random iterations where it's going to be worse. It's pretty much guaranteed that the mutated method is going to be better than the previous list, yeah. Which means that the amount of iterations that this code runs through, especially for the higher levels, will be a lot lower than just if I'd left it completely random. And that's really where the cleverness comes in, I'd say. It's simple, it's easy, but it's something that I believe required a good understanding of genetic algorithms in general. And genetic algorithms is something I really enjoyed in university when I was studying. It's something I did very well in. I didn't get the top marks in the class overall for that particular artificial intelligence course, but what I did get was the top in the class for my tests and everything like that, for genetic algorithms very specifically, by quite a bit actually. I think I got, what was it, like 9 out of 10 or something like that, and the nearest person to me got 7 out of 10 for genetic algorithms and genetic algorithm coding and everything like that. So I really like genetic algorithms. I think they're fascinating. I understand them very, very well, which is why I wanted to showcase them out over here. Because yeah, this code here, I'm very proud of this code. I think it runs well and everything like that. It's efficient, and it's built to be it's built for the job at hand, but it's also built to be scalable. So I hope that if you're looking at this, you get the understanding behind the code and everything like that. And if you've got any suggestions for me to improve this code in the future, I would not mind you having suggestions down below. I will get back to it hopefully at a later date. I am busy with other projects at the moment, so this isn't my top priority. But yes, thank you for watching this video. I hope you have a great day. Goodbye.